To find out how our solar system got here, scientists have been tracing the history of another unusual group of stars. They loop around our galactic disk in a spectacular trail called the Sagittarius Stream.
So the Sagittarius Stream is really interesting because it might actually help us understand where we came from.
It is what's known as a tidal stream, which is a stream of stars that have been stretched across the night sky due to the gravity of the Milky Way.
The Sagittarius Stream is so big, it goes all the way up and even all the way down. So we can just carry the Milky Way from its handle. It's really, really large stream.
The trail of stars we see today is named after the galaxy that they used to belong to, Sagittarius Dwarf.
The Sagittarius galaxy was discovered by a student of myself in the 90s. Most of the Sagittarius galaxy is actually spread out of two streams, one in front and out the back, like giant comet tails wrapping around the entire sky, going out from maybe 100,000 light years away. We could see these, but it wasn't possible to understand how they got there. Now with Gaia, we have motions of these stars, so we can see what direction they're moving in, which ones are going fast, which ones are going slow. For the first time ever, it's been possible to say, this is what happened.
The Sagittarius Stream is essentially the tidal debris that has been left over when a dwarf galaxy, the Sagittarius dwarf, actually plunged into the Milky Way.
By studying the stream of stars, scientists have uncovered the story of a much more recent galactic collision. This time with a much smaller galaxy.
When the Sagittarius galaxy orbited into the Milky Way, it came foolishly rather far in.
As it dives towards the Milky Way, the dwarf galaxy begins to have its stars pulled off.
When it goes through the disk, it punches a hole in the disk, and the stars get put in particular patterns, and it's got stretched into these two great long streams.
The much smaller galaxy encroaches upon the Milky Way, just like Gaia and Enceladus did, but the timing is intriguing because this collision happens just before the birth of our own solar system.
One of the most important consequences of galaxy mergers, like the destruction of the Sagittarius dwarf galaxy by the Milky Way, is a new, fresh injection of gas into the galaxy, right? And it is gas, particularly cold gas, that is the fuel from which all stars are born.
For star formation to occur, basically, the colder, the better.
The most important gas that the collisions bring is made of one of the oldest and most ubiquitous elements in the universe.
So what I'm listening to here is the lifeblood of our galaxy, hydrogen. We can detect it with our radio telescopes, like in this case, pointing right at the Milky Way. Hydrogen is the most common element in the universe, and it's in our own galaxy. We don't see gas with our eyes, and therefore we're not used to the idea of there being plenty of gas in the Milky Way. But if you use a radio telescope, you can see it. You can look at the radiation coming from that gas, and that's exactly what we're doing right now. This gas is connected to stars deeply. It's what stars form from. If this gas wasn't there, stars would never have formed.